Assalamualaikum and greetings to all. In this video, I will present my Bachelor Degree Project 2 entitled Development and Analysis of Chili-padi Baking Robot. Before I start, I would like to introduce myself. I am Afeeq Haikal bin Azhar from Faculty of Manufacturing Engineering. I am under the supervision of Dr. NAZMIN bin MASLAN under the scope of Industrial Automation and Robotics. First and foremost is the project background. This project covers on the development of the Chili-padi picking robot. Generally, the existing design for the Chili-padi picking robot has several structure issues which can be further improved. Due to that reason, this project focuses on the development of the robot structure design and analysis. In addition, it is to help reduce the ergonomic issue posed from the conventional chili harvesting method using human labor. Moving on to the introduction. The problem statement of this project is that the conventional harvesting method of chili-padi by human labor pose threat to the farmers. The harsh working condition which lead farmers to have problems that relates to ergonomic and musculoskeletal disorder (MSD). In addition, the previous design of the chili harvesting robot suffers from the structure problem which can be further improved. As for the objective, there are three objectives. The first objective is to design and improve structure and optimize assembly for the chili-padi picking robot. Next is to evaluate the new design of the robot structural analysis through finite element analysis. And lastly is to analyze the ergonomic factor of the picking robot. Next is the scope of the project. For the first scope, the robot can detect and pick off chili-padi from the tree whilst ensuring the condition of the tree intact. Second, the development and analysis of the robot structure through FEA, specifically on the structural analysis only. And the third one, the robot harvesting capability focuses on the chili-padi tree only. For the first one, the minimum height of the chili-padi harvested is 1.1 meter and maximum of 1.6 meter. Last, this project focuses on the design of the structure and mechatronic components only. For the first part of methodology, I will briefly explain about the flowchart of the project. The procedure of the project starts from the identification of product requirement, which includes the constraint needed for the design of the product. Through this product requirement input, morphological chart for the component of the robot can be generated, hence producing multiple conceptual design through the combination of the component. From this concept, the design will undergo screening and scoring concept to determine the best design for the robot. Once the design has been modeled, the design will undergo analysis to determine whether the objective can be achieved. This is the conceptual design which is generated from the combination of the morphological chart content. There are 5 total numbers of conceptual design produced from the previous step. This design then will be assessed and chosen to proceed to the next process. The design are then screened using the concept screening method through a selection criterion to list out 3 best design. The criteria which is needed to be taken into consideration are durability, toughness, ease to fabricate, mobility, efficiency, stability, and feasibility. From the screening table, concept A, B, and E are selected as it has obtained the highest rank and shall proceed to the next process. After obtaining 3 best design, this concept will then be scored to determine the best design from the same criterion to be used for the fabrication process. Each of the criterion has been given weighted score and rated from 1 to 5. It is then calculated to obtain the final score of the concept. From the table, concept E, which obtains the highest score, has been selected and used as the final project design. This clip is an animation of the new design for the chili-padi picking robot working principle. This is the picking mechanism which combines the gripper and the delta robot. After the chili is picked, it is placed into the storage compartment of the chili. Here is the controller box for the robot. We will proceed to chapter 4, which is result and discussion. The first analysis is the material selection analysis. It is done to identify the best material suited for the structure of the Chili-padi picking robot. The process for this analysis is categorized into three parts, which is translation, screening, and rating. First is to set the performance goal by finding the characteristic required for the design. In this case, tensile strength, fracture toughness, Young modulus, density, yield strength, and price are chosen. Moving on to the second part, the data gathered are then tabulated by screening the constraint with good performance. Thus, 5 materials are chosen, which is zinc alloy, magnesium alloy, stainless steel, titanium alloy, and aluminum alloy. Last, priority rating is applied to obtain the best material. As a result, aluminum alloy has been chosen as the best material suited for the structure of the robot. Next is the finite element analysis. In this analysis, the old design is compared with the new design. From the simulation, the old design has obtained a maximum stress value of 87.4 MN per meter square, while the maximum yield strength is at 55.15 MN per meter square. This is lower than the stress value. As a result of this, it will cause the structure to deform permanently and fail. For the new design, the maximum stress value indicated is at 11.22 MN per meter square. The stress value is lower compared to the yield strength. Deformation that occurs is temporary and may return to the original shape. The maximum stress value acting on the structure is also lower than the previous design, indicating that the new design is superior compared to the old design. Next is the strain analysis. Maximum strain for the design is 5.5 to the power of -4, with the highest strain acting is at the top part of the robot connecting the gantry for the old design. As for the new design, the maximum strain value for the new design is 6.208 to the power of -5, which is slightly lower than the old design. This is due to the gantry having extra support at the end of the part, whereas the old gantry is placed hanging with single support. Proceeding to the displacement analysis, the displacement value of the old design is 20.71 mm. This is due to the strain which affect the displacement value. From the diagram, we can observe that the highest displacement acting at the structure is at the end part of the gantry, where the load or delta robot is applied. The new design has similar maximum displacement, which can be detected at the gantry due to the load hanging. However, it has achieved lower displacement value with a difference of around 20.43 mm. This is around 2 cm in displacement. Both of the gantry will bend in downward directions. For the safety factor, the old design is below 1. This indicates that the project is not safe to be applied. However, for the new design, it has achieved a safety vector value above 1. It is considered safe to be applied. For the last analysis, which is ergonomic analysis, it is used to assess the ergonomic hazard posed by a certain action involving human interaction with a product, tool, or task. In this situation, the posture of human labor harvesting chili-padi while carrying picked chili or load on the field depicts a bending knee posture with slight bending of the trunk. In the simulation, similar posture has been done to assess the posture risk. From the result, there are 3 parts of the body which suffer greatly from the task. The muscle, wrist and arm, neck, trunk and legs are exposed to musculoskeletal disorder. It is more concerning as the average age of farmer is 53 years old. They are at higher risk against the disorder. From the ruler result, it indicates that the posture must be investigated and changed immediately. The task of carrying load during work has affected the L4 to L5 spine. Both methods of carrying load has caused compression and shearing. Although the value is still below the NIOSH action limit and maximum permissible limit, this condition may worsen from time to time, and considering personal health problem, it may take lesser time than expected. In the ruler analysis of the chili-padi picking robot operation, Most of the body part is at good condition and have low exposure to the wrist. This is due to design having good anthropometry and motorized actuator, which reduces the force being exerted to operate the robot. As for the forearm and wrist, the score is moderate due to the operating involved crucially at the both parts. However, the simulation indicates that the posture is acceptable and low risk. For the maintenance process, there are some body parts which suffer from the task like the muscle, neck, trunk and leg part due to the squatting posture which focuses on those parts. Despite that, the posture is still acceptable and can be further improved to avoid ergonomic risks. Lastly is for Chapter 5, Conclusion and Recommendation. In summary, the project has undergoes proper engineering guideline. The outcome of the project has identified the best material suited for the structure of the robot. Furthermore, the development of the robot has been achieved in terms of its structure design. Also, the chili-padi picking robot can help reduce the ergonomic risk in chili harvesting. For further improvement, it is suggested to implement full autonomous ability to the robot by installing GPS tracking system. Other than that, adjustable height can also be emphasized to improve the robot. Lastly, combining different material for the structure of the robot can help improve the strength and durability of the robot. That is all from me. Thank you.